Okay, so in this video, I'm going to explain how to graph certain functions, and each function that I will show will be different to the others. Let's start with the first. So f of x is equal to x squared minus 3. So this function is a quadratic function. So it means the graph of this should be a parabola. It's either opening upward or opening downward. But since this is a positive x squared, so we expect the graph to be in this manner. Okay, now here is the best way, I would say, to graph functions. Okay, so first thing that you have to consider is what is the graph of the most basic quadratic function, and that basic function is f of x equals x squared, because all the other quadratic functions will just be a movement of the graph of f of x equals x squared. And I'll show you how to obtain the graph of x squared minus 3 from the graph of x squared. Okay, so for f of x equals x squared, it is a parabola whose vertex is at 0, 0, and it opens upward. Now to denote more points on the graph, we can identify like numbers 1 and negative 1. When you plug in those values on the function, so we already know that the vertex is at 0, 0. When x is negative 1, when you square negative 1, it's 1. When x is 1, when you square 1, it's also 1. So the point should be here for 1, 1, and then this is for 1 or negative 1, 1. So you can somehow get a more appropriate or a good approximation of the graph of x squared. So now that you know that the graph of f of x equals x squared is the one being graphed here, the graph of f of x equals x squared minus 3. Okay, so this minus 3 is telling us something. If we have a minus 3 on the x squared, it means all the values of x squared will get a deduction of 3 points. So that's a movement 3 units down. So all the points that we identified here, these 3 points, will be moved 3 units down. So if I will graph f of x equals x squared minus 3, the graph of x squared will be moved 3 units down. So a minus 3 means a 3 units down. So same with the other 2 points. So take note, they're just 1 unit higher than the vertex. So if the vertex is now located here, the other 2 points should just be 1 unit higher than the vertex. So try to connect the points again, and that's how you get x squared minus 3. Okay, now do not be confused when the function is like x minus 3 and then squared. Okay, they're not the same. X squared minus 3 means you're subtracting 3 from x squared. So that is why the graph moved down by 3 units. Now the effect of subtracting a number on x inside the parenthesis, okay, if you subtract a number, the graph will move that number of units to the right. If you add a number on the x, the graph will move that certain number of units to the left. So x minus 3 squared will have a graph of x squared move not 3 units to the left but 3 units to the right. So there's no movement on the y, so the vertex will be moved 3 units to the right. Again, the other 2 points will always be 1 unit higher than the vertex. So this will give you this graph. Okay, so that's for x minus 3 squared. Okay, so I hope that's clear. Okay, so that is for the parabola, okay, or quadratic function. Okay, so next, let's have f of x equals x plus 3 cubed. Okay, now the good thing about my explanation for the quadratic function is that all the things that we did to get x squared minus 3, or the graph of x squared minus 3, will be similar to how we will graph x plus 3 cubed. So the key is to know the graph of the basic function of a cube, and that is f of x equals x cubed. And from the x cubed, we will know how to move the graph given that we have x plus 3 cubed. Okay, now if you will forget the orientation of the graph, it's always useful to consider values of x and y. And you could always choose 0, -1, and 1. So when you place the -1 on x, -1 cubed is -1. Place a 0 on x, it's 0. If you place 1 on x, 1 cubed is 1. So that means you have these points 0, 0. You also have -1 for x and -1 for y. Then you could also have 1 on x and then 1 on y. Okay, although they look like you will get a line, a function with degree higher than 1 will always be a curve. Okay, so the curve will be passing through those points in this manner and then this way. So some people will say it's like a reverse S, like in a different orientation. Okay, so it's a curved line following this way. Okay, so how will this be helpful in graphing x plus 3 cubed? Now, if you remember how I graph x minus 3 squared, the minus 3 is telling us to move the graph of x squared 3 units to the right. So for f of x equals x cubed, the plus 3 is telling us to move the graph of x cubed 3 units to the left. So the graph that we need will be, so this is your xy axis. So you have to move, so just select one point and you pick the one in the middle. So this will be moved 3 units to the left. Now those two other points, the one is just 1 unit higher than the middle one, and the other is 1 unit lower than the middle point. So if this is the middle point, the other point should be 1 unit higher, then the third point is 1 unit lower. And try to imitate the graph of x cubed. So this is the graph of f of x equals x plus 3 cubed. Okay, so it's easier now, right? Okay, now let's take a look at another type of function, and that will be, so that's actually our letter C. F of x is equal to 1 over x minus 7. So first thing to do, identify the function, the basic function where this is coming from. It's coming from 1 over x. Okay, Now I'll tell you now the graph of 1 over x. Now since x cannot be equal to 0, you can never get a value at x equals 0. And in this type of function, that would indicate an asymptote. There's a dotted line. This is supposed to be a vertical line. That's the line that you cannot pass through when you plot the graph. Okay, now using some values of x. So if x is 0, there's no value that we can get. If x is negative 1, so try to put negative 1 here. So 1 over negative 1 is negative 1. And then the value here when x is 1 should be 1. So plotting those points, so negative 1, you get this point, and then plotting 1, 1. So 1 on x, 1 on y, you get this point. Okay, the behavior of 1 over x, okay, is like this. Okay, it's not crossing the y-axis. It's not also crossing the x-axis. So it will stay with those boundaries, not crossing x and not crossing y. Now again, once you know the graph of 1 over x, it is now easy to graph y equals 1 over x minus 7. So a minus 7 means, again, from the first two examples, a minus 7 will make this graph move 7 units to the right. So minus 7 will make the graph move to the right. So let's make a new xy axis. So we have now, so 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So if a while ago the vertical line is at 0, 0, so take a look at this asymptote. The vertical line is at 0, so that vertical line will be moved 7 units to the right, and that will make that dotted line place here. And remember the role of that dotted line, that is the boundary. You cannot cross that line. And then try to imitate, or you can place the points first. It's just 1 unit to the left and 1 unit down. Here 1 unit to the right and 1 unit up. Then again, you cannot pass through the asymptote and the x-axis, the asymptote and the x-axis. So this is the graph of 1 over x minus 7. You see? So the behavior is the same. Okay, let's move to another one. F of x is equal to x minus 5. So this came from the graph of the absolute value of x. The absolute value of x follows the V-shaped graph. Okay, so it's here. So you can identify 2 more points. You will be surprised that those points will be just like the other points we obtained from the previous functions. So when x is negative 1, if you place negative 1 on x, means absolute value means you make the number positive, or that's a positive value. So 1, 0 is 0, 1 is 1. So when x is negative 1, you have the point at negative 1, 1. And when x is 1, it's also at 1. So those are the other 2 points that could help us, make a better estimate where the graph should be located. Okay, so again, the same idea. Minus 5 means moving the graph of the absolute value of x 5 units to the right. So if this is the original graph, the final graph should be moved 5 units to the right. So 1, 2, 3, 4, 5. So it's now, so that point here is now placed here, and these other 2 points will just be the guide in forming the new V-shaped graph. Okay, so that is your final graph. So same idea. Okay, the functions are changing, but the way we graph these functions um, is just the same. Okay. Okay, another one. F of x is equal to the square root of x plus 5. The basic function for this is the square root of x. Okay, now for the square root of x, its graph is based from the parabola opening to the right. Okay, now this will have two different graphs depending on the radical function. Okay, so the upper graph is f of x equals the positive square root, and the second graph is when it is negative square root of x. Okay, so if we are graphing square root of x plus 5 and we follow the idea from on how we graph the other functions, now the plus 5 is added to the square root of x. Note it is not we are not adding 5 inside the x, like it's not square root of x plus 5. The square root of x plus 5 means you move the graph 5 units to the left, but plus 5 outside means you have to move the graph 5 units up. So which graph? The graph of the square root of x, and this is what we need. So the final graph that we need should be based on this, but it is moved 5 units up. So 1, 2, 3, 4, 5, and then follow the orientation. Okay, now you can make use of a guide point, which is just 1 unit after, like 1 unit above the point and then 1 unit to the right. So that will be your second point. Okay, so this is the graph of f of x equals the square root of x plus 5. Now to extend the idea, if I have f of x equals the square root of x plus 5, then that would mean the graph will be moved 5 units to the left. So 1, 2, 3, 4, 5. So the point is now here. The second point is just 1 unit to the right and above. So this will be the graph. So make sure that the graph follows a curved path and not a straight line. Okay, so finally, which actually the easiest one, so f of x equals x plus 2, a line, the easiest to graph of all the functions, because all you need to do is to select 2 points for x. So say x is 1, x is 2, you can even use x equals 0 and 1. Okay, but just to use other numbers, let's use 1 and 2. So when x is 1, it's 1 plus 2 or 3. When x is 2, it's 2 plus 2 is 4. So graphing this, so we have when x is 1, the y is at 3. When x is 2, the y is at 4. Okay, this is a linear function, so connecting the 2 points will give you the line, and that's it. Okay, so I hope this video was able to teach you how to graph different functions. Again, graphing them follows a similar method or same method to all. Okay, it's just that the type of graph will just change. Okay, so I think that's it. Just watch the video again when you need to review how to graph these functions.